Next, internal energy. Internal energy is represented with the U. So, now what do you mean by internal energy? The total energy present inside the system due to all sources except due to gravitational force is called internal energy. That means, simply in other words, we can say the sum of kinetic energy and potential energy together is called internal energy. Next, if some amount of energy is present inside the system, a part of the energy will exist as kinetic energy and a part will exist as potential energy. If some amount exists as kinetic energy, a part of the kinetic energy exists as the electronic energy and a small portion of the energy will exist as the rotational energy and a small portion will exist as the vibrational energy and a small portion will exist as the translational energy. Therefore, kinetic energies again exist in various forms as electronic energy, rotational energy, vibrational energy, translational energy. Next, potential energy. What do you mean by potential energy? Potential energy means simply the various types of the attractions that exist between the atoms or molecules or between nuclei and electrons together is called potential energy. Simply various types of the attractions is called potential energy. Next, what do you mean by electronic energy or electronic transitional energy? So, here electronic energy means energy associated during the electronic transition from lower levels to higher levels or higher levels to lower levels within one atom. This is a gas, this is a liquid and this is a solid. So, electronic energy means the energy that is associated with the transition of electrons within the atom between different atoms, between different orbits. Therefore, electronic energy, since it is present inside the atom, so inside the gaseous state atoms, inside the liquid state atoms, inside the solid state atoms, the electronic energy can exist. Next, rotational energy. Rotational energy means energy that is associated with the rotations of the molecules. Since the rotations can take place only in the gaseous state, therefore, this rotational energy will exist only in the gaseous state. Rotational energy do not exist in the liquid state. Rotational energy do not exist in the solid state. Next, vibrations. Vibrations means the to and fro motion shown by the atoms within one molecule is called vibration. During these vibrations, if some amount of energy is associated, that associated energy is called vibrational energy. Therefore, these vibrations are characteristic features of the atoms present inside the molecule. Therefore, whether the molecules are in the gaseous state or liquid state or solid state, this vibrational energy always exists. Therefore, it is a characteristic feature of the all three physical states. Next, translations. Translational motion is a characteristic feature of the gaseous state only. Therefore, in the liquid state and solid state, the molecules cannot exhibit the translations. Hence, translational energy do not exist in the liquid and solid states. Next, these attractions. The degree of attractions, if we compare the gaseous state, liquid state, solid state, in solid state we will find large degree of attractions. Hence, we will find large amount of the potential energy in the solid state. This internal energy, see, it depends on the quantity of the matter. Therefore, it is extensive property. Next, it depends on the initial and final states. Therefore, it is a state variable. It is a state variable. Next, the absolute magnitude of the internal energy cannot be determined through any method. Therefore, only change in internal energy can be determined. Change of internal energy. Change of internal energy can be determined. Change of internal energy del U is equal to internal energy of the final state minus internal energy of the initial state. In case of reactions, in case of the reactions, change in internal energy is equal to internal energy of the products minus internal energy of the reactants. Next, say for example, we have one particular system. This system, inside the system we have taken the gas. Next, this volume of this vessel is being maintained constant, therefore change in volume is 0. Change in volume is 0. That means this system is being maintained at constant volume. Then we are supplying the heat energy to this system. So, to any system which is maintained at constant volume, then if we supply the energy, the expansion work cannot take place, because all gas molecules, they are confined to a fixed volume. Therefore, change in volume is 0, therefore work done by the system is 0. Therefore, when a gas is taken at constant volume, then on supplying energy, the work done by the system becomes 0. But if you continuously supply the energy, therefore the supplied energy will be continuously stored inside the system. As a result, internal energy of the system will increase. Therefore, in general, at constant volume, this is the change in internal energy. This is the heat supplied to a system which is at constant volume. When a system is at constant volume, the total heat supplied to a system is equal to change in internal energy or increase of internal energy. Similarly, when a system is maintained at constant volume, if you decrease the heat energy, that decreases the internal energy. Therefore, Q V is equal to minus del U, or Q V is equal to plus or minus del V. That means the all heat changes taking place at constant volume is equal to internal energy changes.